All right, we're going to do a little extension here at the end of chapter 11 here, talking about what's called the normal distribution. And as we start talking, a lot of standardized tests, like we have with ACTs and MCAs and all those types of ones that you've done or will do, they kind of follow what's called a normal distribution. And probably distributions can be based on this type of data. And so we kind of use this as a way to standardize some different things. So we kind of look at binomial distribution. What's going to happen is that if it's a true false test and you were to strictly guess out of the 10 questions, this is kind of likely what would happen probability wise. And you kind of see this generation of this curve called the normal distribution. And kind of like what we call a bell-shaped curve, and you kind of see it go like that. And in most standardized test scores, that's what happens. And what you're going to notice is that the mean is going to be drop straight down from that peak, and that mean and median are going to be the same number actually right there. And then what we're going to do is we're going to mark off standard deviations. So we're going to go 1, 2, 3 standard deviations above and below the mean. Basically, all of your data should be within that, and obviously not quite as likely to be out 3 standard deviations, but should see a lot of it, or the large majority of it, in between. So some common things that we have here is that the probability assigned to a real number interval is the area under the normal curve in that interval. And because that area of the curve represents probability, if you do the whole area under the curve, it's 1. That adds up all the probabilities. All right, now the maximum value of a normal curve does occur at the mean. It is symmetric, and the normal curve does have a horizontal asymptote there. It never really gets to 0 is what happens there. So here's what we see. In a normal distribution, you'll see these percentages that, we're going to have, 68.2% within that first standard deviation, within 1 standard deviation of the mean. And those percentages kind of split up. You can see very unlikely, a 0.1% chance that you're going to be above 3 standard deviations or below 3 standard deviations there. All right, so a couple things just to kind of put them together is that about 68% lie within 1 standard deviation, 95% will lie within 2 standard deviations of the mean, and almost 100%, 99.8%, are going to lie within 3 standard deviations of the mean. It's not very likely ever that you're above or below those guidelines. So keep that in mind as we look at these. So here we go. So the SAT is designed so that scores are normally distributed, a mean of 500 and a standard deviation of 100. What percent of scores lie between 300 and 500? So what you want to do is draw yourself a normal distribution, and then what you want to do is go straight down from that peak, and that's going to be the mean of 500, and then just mark 1, 2, 3 standard deviations above. Notice that's 100, and 3 standard deviations below, and that kind of then gives you percentages that you can use with the normal distribution. So as we look between 300 and 500, basically we're saying, all right, well, what percentage of the scores are within 2 standard deviations below the mean? Well, basically you're just going to add up those two. You're going to add up the 13.6 and the 34.1. So we'd say about 47.7% would be the scores that would lie between there. Okay. All right, now what's probably that this SAT score is below 700? Now, once again, as we do the percentages here, whoops, I think we did that. Let's do between 400 and 600. Sorry about that, we missed that one. But as we draw out that same curve that we have there, well, once again, we're going to add those percentages. Basically, we know that 100% should be underneath the curve. We're missing that the category where we're within 1 standard deviation. We knew that was about 68%, so we're going to say it's about 32%. You kind of add those all up there, 32, maybe 32.2 if you add up the actual percentages in there. So, but yeah, about 32% is what you would see there. Yeah. All right, so there we go. So that is, once again,